Good afternoon. Today we start a new discipline, physics. We have lecture number 1, kinematics of a material point. We have 3 questions. The first question we will study and physical definition of the displacement, velocity and speed. And the second question in here, the physical characteristics of the motion acceleration. We know acceleration, this is physical characteristic, show you changing of the velocity. And the third question, motion with constant acceleration. And the first question, we will study the physical definition, displacement, velocity, and speed. We know, and mechanics, the first chapter of the physics, we are beginning with the study the first chapter, mechanics, and we know the mechanics and a relationship among force, matter, and motion. The first question, the first lecture, the same kinematics. Kinematics, we will study kinematics, and we know, and this is part of mechanics, and enables us to describe motion. Later, we will study the second characteristics of the mechanics, the second characteristics dynamics, which relates motion to its cases. And today we study and how to describe straight line motion in terms of average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. The second step, we'll study how to interpret a graph of position versus time, velocity versus time, and acceleration versus time for straight line motion. And here this is figure, and the first position, initial position, and the second position of the car, and between two position, and this is distance, changing position delta x, but a car from initial point to final point, the direction of the x axis. And we are now on the definition displacement. Delta x, this is displacement, we know, and the second position minus the first position. We know on the unit of system international unit of the position and meter. Maybe we use on the solve of the problem, maybe, and centimeter, we replace to meter, maybe, and kilometer, we to replace to meter. And the displacement of the dragster during the time interval from to its vector from to the x component, and in here this is figure show you, and the x direction, and displacement change, show change in the coordinate x. And we now maybe, and the first point and start, and the second point in here, this is finish point. We take one one car and point P1 and the position and the time, first time equal 1 second. And second point P2 and the position at the time 4 seconds. And displacement and the changing x and the second position minus and first position equal to 258 meter, but we know, and the second position 277 meter, and final position 19 meter. And displacement show you and changing coordinate. In here, changing x coordinate, and start position. This is x is positive to the right of the origin or and negative to the left of it in here. And we solve average velocity. Average velocity, we know average velocity show you of the ratio changing coordinates divided by changing time. In here we calculated displacement in here. Displacement in here, this is 258 meter. Replace and changing coordinates. And delta t, this is changing time. Because position following at point, the second point, and time equal 4 seconds, position and following and time 1 second. If we know and delta t, this is changing time, and 4 seconds minus 1 second will be and 3 seconds. And calculated average velocity 86 meter divided by second. And here this is a formula of the average velocity. And then in here this is average velocity is positively because and the car move on the to the right, and this is x direction and positively and plus x direction in here. The displacement delta x is positivity 2, so the average velocity positively 2 in here. And maybe we and a car move from the first position and first position x1 equal 277 meter, and move on the left, moved of the left, and the second maybe and final position, and the following second coordinates 19 meter, and time, the second time equal 25 seconds. But we should to calculate of average velocity. But in the x direction, delta x, and in here this is displacement. Displacement will be negatively because the second position and following 19 meter minus the first position 277 meter, and will be displacement will be negatively minus 258 meter. And when we should to calculate of the average velocity of the ratio and displacement divided by delta t, because and delta x and negatively minus 258 meter divided by 9 second, and will be average velocity energy velocity minus 28 meter divided by second. Minus. In here, the first example will be average velocity positively because car move on the right. And the second example show you and the car moved on the left, and average velocity will be negatively minus 28 meter divided by second. We know, and here this is a formula. This is formula average velocity. Average velocity equal of the ratio changing coordinate divided by delta t. But maybe we should to calculate instantaneous velocity. Instantaneous velocity and the notation instantaneous velocity and v and x, vx equal limit delta t approaches zero. Delta t approaches zero and limit and average velocity. And average velocity, I put on the average velocity delta x divided by delta t, and limit delta t approaches zero, delta x divided by delta t, give, and the first derived position divided by dt, and the first derived is dx divided by dt. And this is formula of the instantaneous velocity, And in here, this is a diagram show you, and this is diagram and show you changing x position versus time, because and car moved in the first position and the P1 from first position and to final position P2. We know in here this is the first position following the first coordinate and the first time, and the final position, and P2, and following the second coordinates x2 and second time t2. Okay, and here this is regions following changing time. Changing time will be the second time minus the first time. And here this is changing coordinates. Changing coordinates following x coordinates, because and we car moved on the x direction, and delta x equal the second coordinates minus x coordinates, and here this is slope equal average velocity. In here this is slope average velocity. This is formula delta x divided by delta t. In here, this is slope equal average velocity. But we calculated two instantaneous velocity, and here, this is slope. This is slope, and here slope equal instantaneous velocity. In here. Maybe dragster track not to scale. In here, the first position of the car will move on the x direction in here, and this is position following. And the first coordinates x1 and time t1 in here. The second position and x2 following coordinates x2 and the time the second. And here this is region show you. In here this is, and changing time, and in here this is a region following changing coordinate. This is displacement, and slope equal velocity in here. Slope in here equal average velocity, and here, and the object is average velocity equal slope of line connecting the corresponding points on a graph of position versus time. So in here, slope equal rise over run equal delta x divided by delta t. In here, and following average velocity. This is a three diagram, and x versus time. The first region changing time 2 seconds, and displacement in equal 100. The first diagram, delta x equal 150 meter, and we now formula of the average velocity. Average velocity we now formula, and displacement divided by delta t, and we now displacement 150 meter. 150 meter in here. This is delta x divided by delta t. Delta t following, and this is region following 2 seconds. If we calculated average velocity. Average velocity equal 75 meter divided by second. And here this is slope equal average velocity equals 75 meter divided by second. As we calculated average velocity over shorter time intervals. Shorter time intervals. Maybe we should to calculate instantaneous velocity. Instantaneous velocity, we know instantaneous velocity, this is limit delta t approaches 0 average velocity. And here, okay, and this is diagram x versus time. And this is region, in here, this is time, delta t equal 1 second. And in here, this is region delta x following 55 meter. If we calculated average velocity 55 meter divided by second. 55 meter divided by second. And here it's value. Average velocity approaches the instantaneous velocity. In here is the value in here. This is slope and average velocity. And average velocity approaches the instantaneous velocity. This third diagram, it's 2 x coordinates versus time. But in here, the first position following the first position on the car, P1 equal in here, this is, and here, this is region, I show you from 1 second to 5 seconds. This is region following, and then 4 seconds in here, because and final 5 seconds, and initial time 1 second. It will be 4 seconds. And this is region following, and displacement and 100 160 meter. We now on the slope of tangent equal instantaneous tangent line in here. This is slope of tangent in here equal instantaneous velocity. Instantaneous velocity any given point equals the slope of tangent to the xt curve at the point. And here this is calculated in the first, and here this is position. Here this is position, and instantaneous velocity will be 40 meter divided by second. In here, this is instantaneous velocity. Then in here, this is we study and the first characteristic of the motion. We now on the motion we had and two characteristics. The first characteristic velocity. And velocity show you and changing motion. And the second characteristic acceleration. The second characteristic acceleration. If we now and two type and here, and we study in here and average acceleration and instantaneous acceleration too. And we define the average acceleration of the particle. It moves from initial position in here. This is from initial position following and the first in here velocity, in here in following the time t1 from car moved from initial position to final position, and to be vector quantity with a component in here average, called average acceleration. And average acceleration formula of the average acceleration and the change of the velocity divided by the time interval delta t. In here, these are regions following time interval delta t, second time minus the first time, and here this is region following changing velocity delta v and x direction, and equals the second acceleration minus first acceleration. I'm sorry. In here, delta v equal delta v and changing velocity. The second velocity minus first velocity. Okay, but we know and average acceleration and will be and limit delta t approaches 0 and the average velocity will be the first derived velocity divided by time. But we know and that this is formula in here will be formula of the instantaneous acceleration at the point. In here, this is diagram v versus time, velocity versus time. And for in here, this is slope equal average acceleration. Slope. For and here, this is for a displacement following in here. For a displacement along the x-axis, an object average x acceleration equal the slope of line connecting the corresponding points on the graph velocity versus time. In this is equal, slope equal average acceleration, but we know, and in here, this is the slope of tangent, to VXT curve, and the given point will be instantaneous acceleration at the point. In here, this is slope equal average acceleration. In here, this is slope equal instantaneous acceleration at the point. Now, and the first characteristics, velocity. The second characteristics, and acceleration. Velocity will be average velocity and instantaneous velocity. And here, this is acceleration, the second characteristic, and will be average acceleration and instantaneous acceleration. Average acceleration show you changing velocity to interval time, and instantaneous velocity, the first derived acceleration divided by time. But in the second derived and position divided by time. And the final question, motion with a constant acceleration. In here, maybe in the first diagram, and acceleration versus time, and this is a horizontal line show you, and acceleration is a constant. And slope equals zero, because acceleration is a constant. In here, area under and 80 graph equal changing velocity from time zero to time t. In here, this is area, and slope equals zero. And this is figure. Maybe we take the first position, in here, this is direction. If a particle moves in straight line in here with a constant x acceleration, in here, and time equals zero. But and time, when time equal changing time delta t, the velocity changing by equal amounts in equal time interval. This is direction of the straight line. But and equal second and third time equal two time interval will be the x velocity changing by equal amounts is a time interval 2 in here, and then 3 time interval changing velocity by equal amounts in the equal time interval 2. And final 4 time interval, it's 2 changing velocity by equal amounts. It's the equal time interval. And the position change in here. This is position in here, changing position. Because and the straight line, the car moved on the straight line, and the position change by different amounts in equal time interval, because the velocity is changing too. velocity and changing too. In here, and in here, and here I take one car. I take one car. The first position of the car and x position x0, and the first position. The second position x. This is position. This is position, and during time interval t, time interval t, the velocity change because and final velocity minus the initial velocity equal acceleration multiplied by t, acceleration multiplied by t. The car moves in x direction with the constant acceleration, and feature following and diagram in here. And here we draw the xt graph, x versus time graph in here. And the first position of the car, x0, and the second position of the car x, and here and position and versus time, and this is time interval. This is time interval. This is displacement, and here this is line show and line following of the acceleration, the constant, because then with the acceleration is the constant, and x versus t graph is a parabola, because the constant acceleration, and slope in here. This is slope following instantaneous velocity. This is slope. This is tangent line following tangent line we know, and this is line, and in here this is line, tangent line, the first position, and the second position, and tangent line the second. And the first tangent line following, and in here this is slope equal the initial instantaneous velocity and the final instantaneous velocity. And here, in here, and we should to write a formula of the final velocity. Final velocity will be the initial velocity plus acceleration multiplied by time. In here. This is equation of the motion. In here, this is two diagram. The first diagram, part number A, and xt graph for an object moving with a positive constant acceleration, positive. And this is equation of the motion. X equal x0 initial position plus initial velocity multiplied by t plus 1 divided by 2 at square. This is the graph with the constant acceleration, and this is equation following in this line in here show. Okay, because if we take acceleration equals 0, and equation of the motion x equal x0 plus v0 multiplied by t, because acceleration is a constant. If this is line, dashed line, show you the graph we would get with zero acceleration. In here, this is dashed line show dashed line following this equation, and maybe acceleration is not equal zero. The effect acceleration of the equation, and here this is plus 80 squared divided by 2. And here this is effect of acceleration. And effect of the acceleration is this line, perpendicular line on the dashed line, the effect of of acceleration, 80 squared divided by 2. But the second diagram and V and T, T graph for the sum object, Okay, and initial velocity equals zero. And the graph with the constant acceleration, in here, because initial acceleration, initial velocity equals zero, and final velocity equal a acceleration multiplied by t. And the first when and the initial acceleration equal final initial velocity, initial velocity equal final velocity. And here this is dashed line show you the graph following with zero acceleration. In here. But and the when and here v0 plus ax multiplied by t. Then in here added velocity due acceleration, and this effect of acceleration a multiplied by t. And this is perpendicular line of the dashed line, show you the effect acceleration a multiplied by t. In here, this is the graph following the graph with the constant x acceleration. And final figure with the in here, and motion with the constant acceleration, overtaking motion with the constant velocity, and b graph and x versus time for each point in here, and in here this is position and police officer initially at the rest, and the constant acceleration with and moved police officer on the with the constant acceleration and 3 meters divided by square second. But in here this is position motorist with the constant velocity. This is initial velocity 15 meters divided by second, and this is figure show you position of the different body, different object, and the B graph show you and equation of the motion. But we know, and here this is the line following the motion of police officer, and the police officer, and here this is motorist, the lines following of the motion, motorist. When this is a point, the point and meet at the time t, where there x3 graph cross. And this is point following on the mid at the time t, at the time t. And on the diagram x versus time, x versus time. And we study the motion and the physical definition of the displacement and characteristics of the motion, velocity and acceleration, and we studied and motion with a constant acceleration today. Thank you for attention.